In this video, we're going to discuss the types of variables that we might run into in statistics. And so we're going to start with two main categories. We're going to either have qualitative, which is sometimes called categorical, or quantitative, which is going to be numerical. And so we're going to start with qualitative, which is, like we said, also categorical. And this is data that consists of names or labels that are not numbers representing counts or measurements. So examples might include political party affiliation, so responses to that, so possible values of political party affiliation would be Democrat, Republican, Independent, maybe Libertarian. Those are some examples. And you'll notice none of those are numeric. None of them represent counts or measurements. They're just a political party. Maybe gender, species of duck, eye color, or area code. And I threw an area code here, which area code is numeric, but it's still considered qualitative categorical data because the numbers in the area code are just used to kind of categorize. They're not actually something meaningful in terms of the size of the number or like taking the average area code. Okay. The other type of variable we're going to discuss is quantitative, which is a numerical data value. And this usually consists of numbers that represent counts or measurements, where things like reporting an average would make sense. So again, where an average area code would be useless, an average income is a meaningful number, okay? So examples include an item's weight, annual income, number of children, amount of rainfall. All of those would be values resulting from counting or measuring something, and so those would be quantitative. Once we have categorized data as quantitative, there are two subcategories of quantitative variables. So the first of those is a discrete quantitative variable, and a discrete variable is one that takes on a finite, means it has an ending, or countably infinite number of observations. So if we were to ask individuals how many children they had, answers might be 0, 1, 2, 3, 4, 5, etc., which is a finite number of possible outcomes. If we looked at measuring the number of elk in the continental United States, that's another thing that would be a count. Countably infinite means we can count it, but essentially it's infinite and would take us forever to get there. So examples might be like number of grains of sand on a beach or stars in the sky, that type of thing. So what you'll mainly notice here about the examples we looked at for discrete is that they are usually a count of something. On the other hand, the other type of quantitative variable is going to be a continuous quantitative variable. And this is one where rather than a count, it's usually taking on a measurement, and it can be any value within an interval. So whereas discrete is, like we said, usually a count, so it's usually going to be whole number values. Continuous could be any value within an interval. So examples might include an individual's weight. Again, it's not like you could only weigh 167 pounds or 168 pounds. You could weigh 167.513 pounds, right? So we're not looking at a count, we're looking at a measurement. Other examples might include rainfall, amount of time spent waiting in line for a movie. Time is always continuous, so anything that we're measuring would fall under continuous. So just to give you kind of a visual here, if we're looking at types of variables, we said we either have qualitative or quantitative. But if we decide it's quantitative, there are two subcategories, which are either discrete, that's your count, or continuous, which is your measurement. Okay, so sometimes it kind of helps me to see something visually organized, helps me remember it better, so that's just kind of a visual organization of those definitions we just looked at. one other thing on this video we're going to talk about are different levels of measurement. So measurement in terms of how we are collecting data and what values our variables can take on. So there are 4 types of levels of measurement. The first one is nominal, and this is going to be qualitative data. So there's no meaningful order to the outcomes. Examples might include someone's favorite sport, a team mascot, types of flower. So students' names, for all of those, there's no meaningful order. They're just qualitative data values. Ordinal is where data is measured using an ordinal scale, and the data can be ordered. So you might have something like the top 5 community colleges in the nation. An ordinal scale would rank that as 1 through 5, right? So you might still be looking at teams, but they'd have a ranking. They also might have verbal rankings like poor, fair, good, or excellent. So that's ordinal. Interval is going to be examples where we have data that's numeric and has an order, but it's only applied to data that does not have a starting point. Okay, so temperatures measured in Celsius and Fahrenheit are examples of an interval scale, since in both cases a temperature of 0 is not the absolute lowest temperature, so 0 wouldn't be a starting point there. And then ratio scale is probably the most common type that you'll run into. Ratio is data that's measured, that's numeric, has a definite order, and has a 0 point. So measurements like height, weight, rainfall, test scores, all of those are examples of ratio scales, since a value of 0 is a starting point and a minimum value there.